Hello and welcome to another one of D's ADD videos. Today we're going to discuss the concept of energy. There are some fundamental terms that you should be familiar with if you're going to properly discuss energy. Now when we're talking about heat, we're going to be talking about the transfer of energy due to a temperature difference in the objects that are transferring the energy. And a state function is any property that depends on the object's current state. And I do not mean by state liquid or solid or gas. I mean pressure, volume, things of that sort. And when we're discussing energy, there are a few different types. There's kinetic energy and potential energy. The kinetic energy is due to the energy of motion and is dependent on the mass, m, and the velocity, v. The SI unit for it is the joule. The potential energy, instead of dealing with the energy of motion, it's going to be the energy of position. So depending on how high up an object might have in its mass, it'll have a specific potential energy in joules. I made a little video for you guys to see the difference between potential and kinetic energy. Okay, so basically that was a little excerpt from the Incredible Hulk. I got angry because some of you guys aren't watching my videos. Well, bulk of you are. But it was a little fun in order to explain the difference between the potential and the kinetic energy. At first, when the ball is way up here, it's all potential energy depending on the height of this building and the mass of that ball. Now, whenever I then push the ball, after I do my little incredible scientist transformation, now because it's starting to move, it's now 1/2 mv squared. There's less and less potential energy as this ball is coming down until there's none because the height is 0. And there's no kinetic energy at the bottom either because the velocity is also 0. So those are the two main energies. We'll also describe the internal energy as the sum of all energies of all the individual particles of a sample of matter. And typically when you see this Greek letter delta, the triangle, that means change, and it's usually final minus initial. So in this case, when we're dealing with a chemical reaction, it's going to be the final, which is the products, minus the reactants. When we're dealing with energy being absorbed, that's an endothermic reaction. E will be greater than 0, or we'll also say Q, which we will see soon enough that it will be Q when we're discussing the energy that's being transferred. And if it's less than 0, it's an exothermic reaction, and the system's giving off energy to the surroundings. Okay? All these have their own signs. You should know them. You should also know the work being done in the different scenarios. So here's a little graph of kinetic energy versus the proportion of particles that have that given kinetic energy. The orange is going to be a lower temperature versus the red, a higher temperature. Now, because the lower temperature has particles or molecules that are moving at lower velocities, they all bulk up right to the lower end of the kinetic energy. But as the temperature gets higher, what happens is this curve will tend to flatten out because more and more of the molecules that were here will be traveling faster, and then they'll start to get a bigger kinetic energy. So that's what all this says. And it'll eventually start to widen out the higher and higher the temperature goes. Okay? So that's the basics of energy Make sure you understand the difference between kinetic and potential, internal energy, how to calculate it. Temperature is the average kinetic energy. It's a measure of the average kinetic energy of a sample's atoms and molecules. So I hope I've clarified any doubt that you might have over your basic understanding of energy. Make sure you check out the example videos. Practice, practice, practice as always. Thank you and have a nice day.